Hello everyone, I am Su Yan. I am currently an algorithm engineer at Xianyu Department of Alibaba Group. Xianyu is one of the largest online flea market platforms in China, and to be honest, it is actually the largest one. We are here presenting Fish Bargain, an LLM-empowered bargaining agent for online flea market platform seller. Different from traditional business-to-consumer e-commerce platforms, for example, Amazon, online flea market platforms, for example, Craigslist, mainly focus on individual sellers who are lack of time investment and business proficiency. Individual sellers often struggle with the bargaining process and thus the deal is unaccomplished. Recent advancements in large language models, LLMs, demonstrate huge potential in various dialogue tasks, but those tasks are mainly in the form of passively following users' instruction. Bargaining, as a form of proactive dialogue task, represents a distinct art of dialogue considering the dynamism of environment and uncertainty of adversary strategies. In this paper, we propose an LLM-empowered bargaining agent designed for online flea market platform sellers, named as Fish Bargain. Specifically, Fish Bargain understands the chat context and product information, chooses both action and language skill considering possible adversary actions and generates utterances. Fish Bargain has been tested by thousands of individual sellers on Xianyu. Both qualitative and quantitative experiments demonstrate that Fish Bargain can effectively help sellers make more deals. The system consists of 3 modules: Price Extractor, Policy Planner and Utterance Generator, aiming to automate and improve the bargaining process on flea market platforms for individual sellers. Our contributions are threefold. First, directly applying LLMs to generate responses often results in degenerate solutions because it is challenging to control and interpret the strategies. Preliminary investigations have attempted to address this by decoupling strategy selection from utterance generation. However, generated utterances tend to be repetitive if the same action is chosen. Therefore, we take a step forward to divide strategies into both actions and language skills and introduce a policy planner to choose strategies. This methodology allows for a more nuanced and enriched expression in the generated utterances. Second, rather than passively responding to the buyers, bargaining agents should have proactivity, defined as the capability to control the conversation considering the adversary actions and goals. So instead of choosing strategies only based on chat history, the policy planner is designed to conduct bidirectional thinking, by anticipating the adversary's strategies. Third, we define solid metrics and involve real sellers from Xianyu, to test our bargaining agent. Price is a fundamental element in the bargaining process, but it is challenging for LLMs to interpret this factor. So we introduce a price extractor to alleviate the problem and keep track of the dynamics of buyers' offers. In the bargaining process, price can be expressed through absolute ways, for example, is 200 okay, and relative ways, for example, how about a 20% discount? To address the problem, the price extractor is required to extract the price according to chat history and also provide a detailed computation chain of thought to ensure the precision. LLMs have demonstrated excellent contextual understanding abilities across various dialogue tasks. However, most dialogues are still primarily human-led. In other words, it is challenging for LLMs to strategically guide conversations toward the desired objectives, such as closing a deal at a higher price. To enable LLMs to proactively guide dialogues towards certain goals, we reference previous work by defining and executing bargaining actions to steer the direction of the conversation, with specific bargaining actions detailed in table. After selecting the action to execute, the LLM needs to generate a corresponding response. However, LLMs are not naturally negotiation experts and tend to produce similar expressions when repeatedly executing the same bargaining actions. Therefore, we use LLM to choose language skills as well. In bargaining dialogues, the challenge lies not only in deciding the next action but also in the asymmetric and incomplete information game. Therefore, besides inferring one's actions based on the available information, it is also necessary to anticipate the actions the other party might take in the future to reflect on the rationality of one's own actions. We refer to this process as bidirectional thinking. We use bidirectional thinking to enable LLMs to better achieve bargaining objectives. In order to positively influence the bargaining process, the utterances generated should comprehensively integrate the policy planner's decision on action and language skill. Specifically, if the action chosen is price-related such as counter, we need to additionally generate a price based on the latest buyer's offer and seller's bottom price. In line with previous research on bargaining dialogue, we focus on dialogue-level interactive evaluation. To this end, we employ the average turn and the success rate for the automatic assessment of goal achievement, and we use the sale-to-list ratio as a measure of goal achievement effectiveness in bargaining dialogues. Specifically, AD measures the efficiency of goal completion by calculating the average number of turns to achieve it, while SR assesses the effectiveness of goal completion by calculating the success rate within a predetermined maximum number of turns. We conduct a human evaluation on 100 randomly sampled dialogues, where 3 annotators compare the baseline's generated responses with those from Fishbargain. To evaluate the proposed system, we use GPT to judge transaction occurrences and prices at each turn, with results shown in the table. For human evaluation, we assess 4 indicators: persuasive, coherent, natural, and overall. As shown in the table, Fishbargain generally outperforms other agents in human evaluation, except for a higher win rate in natural by adding price extractor. Here are 2 case studied. The first one is comparison before and after adding the price extractor. Without price extractor, pure LLMs cannot manage the numbers well and can have severe hallucination. Another one is comparison before and after adding the policy planner. Without policy planner, LLMs tend to passively agree to instructions, lack of pervasive ability and proactivity. In conclusion, this paper presents a meaningful dialogue task, bargaining, derived from real user scenarios observed from online flea market platforms. Directly applying LLMs to this task yields unsatisfactory results due to its proactive and quantitative nature. To address these issues, we propose a price extractor, policy planner, and utterance generator, forming the bargaining agent called Fishbargain. Fishbargain enhances the user experience for individual sellers on Xianyu, allowing those with limited time and bargaining skills to make more deals. Fishbargain just started as a project, demonstrating significant potential for more development and refinement. In the future, we will focus on more domain knowledge, better planner, and other aspects to continue optimizing the system. In conclusion, Fishbargain represents a substantial step forward in creating effective bargaining agents, and as we continue to improve the whole system, it will be more intelligent and provide better user experience. So, that's it. Thank you for listening.